We are live. Okay. Yeah. Hello, people. Hello, hello. देखिए transparent. Hello, people. Hello, hello. Yeah. கேக்குது பக்கா. Okay. Hello, hello, everyone. Yeah. I, as usual, class ஆரம்பிக்கு முன்னாடி நான் ஸ்லைட் ஆட் பண்ணிருக்கணும். ஆனால் லாஸ் ஆஃப் மோஷன் சால்வ் பண்ணுறது டஃப்பாக இருக்குண்ணா. யோனிக்ஸ். லாஸ் ஆஃப் மோஷன். சி அந்த சாப்டர் இட்ஸ் சிம்பிள் தான். ஓகே, கொஞ்சம் மெக்கானிக்ஸில் வந்து இட்ஸ் லிட்டில் காம்ப்ளிகேட்டட். லாஸ் ஆஃப் மோஷன் கொஞ்சம் பெரிய சாப்டர் தான். ஸோ வாட் யூ ஹேவ் டு டூ, ஸோ யூ ஹேவ் அதில் வந்து மொமெண்டம் and then force and then you have friction. Okay, force வச்சு friction is also a force. Okay, you have types of force and then pulley base பண்ணி questions இருக்கு. Yeah, so அவ்வளோதான். relative stuffs also will apply. ஆமாம். Yeah. I would like, இப்போ உங்களுக்கு வந்து questions கஷ்டமாக இருக்குன்னா, are you able to solve them and not get the answer correct, or are you not able to even attempt பண்ண கூட முடியாமல் அந்த மாதிரி இருக்கா? If you are not able to if you're able to solve it ஓரளவுக்கு and then you're not able to do it na, that means your concepts are கொஞ்சம் weak. Okay, கான்செப்ட் கிளியராக இருந்துச்சுன்னா ப்ராப்பராக சால்வ் பண்ணிடலாம். அதே வந்து if you are not even able to solve it na, that means your concepts are even worse. Okay, you know few formulas அதை வச்சு அப்ளை பண்ண முடியும். ஓகே, அந்த ஃபார்முலாஸை அப்ளை பண்ண தெரியாமல் இல்லை அப்ளை எப்படி பண்ணணும் தெரியாமல் இருந்துச்சுன்னா யூ மஸ்ட் லேர்ன் ஸ்டஃப். ஓகே, இன் மை ஒப்பீனியன் ஸ்டார்ட் வித் the basic stuff. Okay, how we derive momentum, how we derive force அதுக்கப்புறம், and then அதுலேருந்து impulse தனியாக இருக்கும், and then அதுலேருந்து you have friction, how friction works. கொஞ்சமாக if you understand it properly you will be able to answer. Take any question. Okay, என்ன கொஷினாக இருந்தாலும் you will be able to solve. Okay. ஆனால் பயோவில் 300 above வரக்கு ஐடியா கொடுங்க. ரைட் நாலேஜ் ஃபிசிக்ஸ் மார்க்ஸ் ஒரு எக்ஸாம் நல்லா வருது, ஒரு எக்ஸாம் நல்லா வர மாட்டேங்குது. ஹவு டு சே கன்சியூமிங் மார்க்ஸ். ஓகே, ஃபியூச்சர் டாக்டர், ஹோப்ஃபுல்லி யூ பிகம் ஒன். பயோவில் 300 above வர ஐடியா கொடுங்க. பயாலஜி, சி you have 2 subjects. Okay, everyone knows 180 188, so 360 marks in total. for if you're aiming just 300 போதும் எனக்கு அப்படின்னு நினச்சிங்கன்னா 150 split maybe என்ன வேணாலும் ஸ்பிளிட் இருக்கலாம். Okay, but the only resource for to which you must stick to now is NCERT. Okay, at 11th and 12th NCERT books. அதுக்கு வெளியே they won't ask questions. Okay, biology la questions are either multiple choice question, all are multiple choice question. அதில் வந்து you have MCQ, it's direct one word மாதிரி இருக்கும். You'll have match the following, you have statement based, you have assertion reason. Okay, இது தவிர there will be some pictorial. Okay, these are the 5 forms of questions which may come, which are coming from biology. Okay, direct NCERT linde they would remove a word, they would ask you what it is. Okay, adu enadhu they'll ask year ah iruktom, scientist pair ah iruktom, say a species oda pair, anything. Idukku everything has a common link. Okay, match the following. The direct question வந்து கொஞ்சம் காம்ப்ளிகேட்டாக கொடுத்துருப்பாங்க. Okay, fine. Pictorial also from NCERT. Statements, you have NCERT lines அப்படியே கொடுத்துருப்பாங்க, அவர் கொஞ்சம் மாடிஃபை பண்ணி வாட் எவர் that line actually is trying to say, அதை வந்து they would have given it to you. Assertion reasoning is also, you have an assertion statement from NCERT, or it will be modified to be to an extent where it becomes wrong. And then you have reasoning, which will also sometimes come from NCERT, so that you'll have distinct statements, or you'll have an assertion and a reason which are entirely wrong. Okay, but the common thing is every statement or question comes from NCERT. Okay, so அதை மட்டும் தரவாக படிங்க. You will have கொஞ்சம் difficulty in animal kingdom chapters, plant kingdom, morphology of flowering plants, anatomy of flowering plants, genetics la. And in the chapter எல்லாத்துலேயும் தான் வந்து they will ask questions more. Okay, bio la. Then you have human physiology. அது simple, human physiology is simple. People will be able to understand it. And அதுலேருந்து கொஞ்சம் application based if they ask questions, if you might not be able to answer. Okay, so focus on like the major this is ஒரு entire unit. Okay, animal kingdom, plant kingdom, morphology, anatomy, genetics, இதெல்லாம் தான் வந்து these are the places where the examiner tricks you into thinking you are right and then ending up wrong. அந்த மாதிரி கொஷின்ஸ்லாம் வந்து இதுலேருந்து வரும். இதுக்கப்புறம் ஃபுல் ஃபேக்சுவல் பேஸ்டாக இருக்குது. தீஸ் ஆர் ஆல் கொஞ்சம் கான்செப்சுவல். See, animal kingdom, it comes here because you have ecology, which is ரொம்ப ட்ரையான டாபிக் with a lot of straightforward questions. அதுலேருந்து you will have ecology in the question once. It was straight, pakka line, NCERT line, copy paste in question in NEET exam. Okay, so you have pakka direct questions from that. Okay, இதுக்கப்புறம் you have biotechnology, அந்த சாப்டர்ஸ் எல்லாம் இருக்குது, அதெல்லாமே இதில் தான் வரும். பயோடெக். my suggestion would be study biology in a way that you remember stuff. Okay, what I did was I wrote down என்னோட NCERT புக் இப்படி இருக்குன்னா, this is the page, அங்கே வந்து கொஞ்சம் ஸ்பேஸ் இருக்கும் இப்படி, அதுக்கப்புறம் இங்கே ஃபுல்லாக கண்டென்ட் இருக்கும், அண்ட் இந்த ஸ்பேஸில் யூஸ் ரைட் டவுன் ஸ்டஃப். இந்த பேஜோட சம்மரியை ஐ யூஸ் டு ரைட் இட் டவுன் இந்த பக்கம் இங்கே ஐ ரைட் இட் டவுன் ஆர் நான் அந்த பேஜில் ஐ would have made some mistake ஓகே நான் வந்து மார்க் டெஸ்ட்லையோ இல்லை வீக்லி டெஸ்ட்லையோ ஐ would have made some mistake from that exact line அந்த லைனில் வந்து I would have highlighted that point and I would have written it down here. So நான் எழுதி எரிச்சிருப்பேன். So when I revise it in the chapter, I don't have to go line by line because 90% I would have retained it. கொஞ்சம் சேஞ்சஸ் இருக்கும், அதெல்லாம் வந்து I would have repeatedly மறந்துட்டே இருந்திருப்பேன். அதை வந்து நான் இங்கே எழுதி வச்சுப்பேன். So it was helpful for me. Yeah, initially I didn't do bio well as well. Okay, 300 was a pretty high score for me. All right. ஃபிசிக்ஸ் ஒரு எக்ஸாம் நல்லா வருது, ஒரு எக்ஸாம் நல்லா வர மாட்டேங்குதுண்ணா. எப்போவுமே அதை எக்ஸ்பெக்ட் பண்ண முடியாது ஃபார் இட் டு பி குட் இன் ஃபார் யூ டு பெர்ஃபார்ம் குட் இன் எவ்ரி எக்ஸாம். ஓகே, ஐ டிடன்ட் டு ஃபிசிக்ஸ் குட் இன் எவ்ரி எக்ஸாம். நோ ஒன் ஹாஸ் எவர் டன் அந்த மாதிரி. The only thing you can do after not doing good in exam is learn. Okay, and the exam lende whatever mistake you did and the questions alla practice it again. Okay, practice it in such a way that you understand the concept well, you understand the application of whatever formula you're using there, and அந்த கான்செப்ட் பேஸ் பண்ணி இன்னும் நிறைய கொஸ்டின் சால்வ் பண்ணுங்க, so that you will be able to retain it. Okay, that's all we can do, because question paper, it will be easy sometimes, it will be easier to us sometimes, it will be difficult to us sometimes, general easier இருக்கலாம். ஸோ அது சொல்ல முடியாது. ஓகே ஓகே ஃபைன். டியூரிங் மார்க் டெஸ்ட் வரும்போது மார்க் டெஸ்ட்னு சொல்லிட்டிங்கன்னா there will be fluctuation. Okay, ultimately the only thing you can do is learn from your mistakes. அதை வந்து ட்ரை நாட் டு ரிப்பீட் இட் அகேன். தட்ஸ் தி பெஸ்ட் திங் யூ கேன் டூ. அண்ட் இஃப் யூ டிட் நோ ஃபியூ கான்செப்ட்னா அதை அப்பப்போ படிச்சுக்கோங்க, இட் வில் பி ஹெல்ப்ஃபுல். ஓகே, டன். அண்ணா ஃபிசிக்ஸ் கெமிஸ்ட்ரி பயோ டெய்லி எவ்வளோ சால்வ் பண்ணால் கரெக்டாக இருக்கும்? ஓகே, physics, chemistry, biology, I didn't solve அவ்வளோவா for biology, but for physics and chemistry நிறைய சால்வ் பண்ணேன். biology வந்து my preparation was entirely on revising NCERT so many times. ஏன்னா எங்கள் ஸ்கூலில் my senior was there. Okay, he told us everything that within right before writing NEET examination. Okay, before getting into the examination hall, you should have studied it like 25 to 30 times, entire book, line to line. Okay, அந்த ஒரு தாட் தான் எனக்கு ஓடிட்டு இருந்துச்சு. ஸோ ஐ only read it maximum how many times I was able to, because எவ்வளோ if you read பண்ண ஒன்று the time it takes to complete one chapter, it reduces போக. Okay, 2, you will be able to retain stuff more. நீ எவ்வளோ பார்க்குறியோ, அந்த லைன் பார்க்குற, அந்த பேஜ் பார்க்குற, ஈவன் அ மைன்யூட் சேஞ்ச், ஈவன் அ சின்ன சேஞ்ச். எங்கள் எக்ஸாமில் they had a picture from NCERT for biology. Okay, that picture from NCERT, they had modified it a little bit. Okay, it was from seed or மோனோகாட் சீட், டைகாட் சீடு அதோட மார்க்கிங் வச்சு தான். அதில் வந்து they had an arrow mark கொஞ்சம் தள்ளி. ஓகே, இட் வாஸ் இன் என்சிஆர்டி. என்சிஆர்டியில் ஒரு பாயிண்ட் இருக்குன்னா அந்த பாயிண்ட்லேருந்து தள்ளி கொஞ்சம் தூரத்துலேயே they had one point. Okay, it didn't interfere anything else. Many of us thought that many of the people who wrote the exam thought that it was the wrong one. Okay, அதனால் அது வேறு பாட்டுன்னு மார்க் பண்ணிட்டாங்க. But when I saw it more and I remember the lines that saying that this is இவ்வளோ எக்ஸ்டென்ட்க்கு இது இருக்குது அப்படின்ட்டு, I don't remember it. Okay, I'm sorry. But இந்த இவ்வளோ எக்ஸ்டென்ட்க்கு இது இருக்குன்னு தெரிஞ்சோடனே it gave me upper hand, because all those times of revision. Now for physics and chemistry, I practice questions, okay. எங்களுக்கு மெட்டீரியல் ஒன்று இருக்கும், they you provide us in institution, அதை ஃபுல்லாக சால்வ் பண்ணுவோம். And then there are so many free mock tests available, okay. அதெல்லாம் நான் பார்த்து சும்மா சால்வ் பண்ணிட்டே இருப்பேன். சின்ன சின்ன 15 questions, 20 questions, 30 questions அந்த மாதிரிலாம் இருக்கும் நிறையா. அதை சால்வ் பண்ணுவேன். So yeah, for physics and chemistry இப்படி தான் போச்சு. Organic chemistry I used to study, and inorganic chemistry revision தான். I have a note in the note. This is my 11th and 12th standard. I don't know if you could see it. இதில் வந்து for inorganic chemistry மட்டும் I have few shortcuts done. This is entirely for chemistry மட்டும். இது இங்கே வச்சுட்டு போயிட்டேன், பேக்லேயே இருக்குது. Just give me a second. Yeah, I used to draw graphs இந்த மாதிரி for inorganic chemistry relations எல்லாம். இந்த மாதிரி graphs வச்சு I used to remember stuff. இப்போது ஏன்னா there is nothing much they can ask from. எங்களுக்கு நிறைய ரியாக்ஷன்ஸ் எல்லாம் delete பண்ணிட்டாங்க. ஸோ இப்போது என்ன மாதிரி எழுதியிருக்கேன்னா, I have a graph இங்கே. அதில் வந்து this is for ionization enthalpy, okay. Ionization enthalpy. This is my atomic number of 13th group. அதில் வந்து it goes like, I don't remember it, but இதே வந்து it helped me in exam. I drew this on exam paperல. இது இந்த மாதிரி போகுது. This is for 13th group elements, okay. எழுதியிருக்கேன். This is boron, this is aluminum, this is gallium, this is indium, this is thallium. So based on this diagram, I know for a sure that boron oda aluminum oda ionization enthalpy is low, and gallium is somewhere between thallium and indium aluminum adukku mele, and thallium ku keela. Indium has the least, and thallium has the second highest. Gallium vida the mele irukinte I knew. ஓகே, இந்த மாதிரி தான் வந்து ஐ யூஸ் ரிமெம்பர், பிகாஸ் டேரெக்டான வேல்யூஸ் கேட்டால் இட்ஸ் டிஃபிகல்ட் டு ரிமெம்பர். பட் இந்த மாதிரி கம்பேரிசன் வச்சு பண்ணிக்கலாம். ஓகே, திஸ் ஃபிசிக்ஸ் கிளாஸ், பட் கெமிஸ்ட்ரி ஏன் பண்ணுறதில்ல. ஹவு மெனி ஃபுல் மார்க் டெஸ்ட் தருவோன்னா, ஐ கேவ் அரவுண்ட் 2 to 3 மார்க் டெஸ்ட் அ டே என்டையர் மந்த் ஆஃப் ஏப்ரல் மாதம் ஃபுல்லாக 2லேருந்து 3 மார்க் டெஸ்ட் கொடுத்துட்டே இருந்தேன். Yeah, it did go well. First எழுதுன மார்க் டெஸ்ட் வந்து I scored around 400 something. Okay, it was in my January. சும்மா ட்ரை பண்ணலான்ட்டு, சிலபஸ் முடிக்கல, சும்மா ட்ரை பண்ணலான்னு எழுதிட்டு. அதுக்கப்புறம் போக போக gradually scored improved, because I had my faculties, they helped me. ஹெல்ப் பண்ணதை விட they told me that error correction is important. So I followed it கரெக்டாக. And then போக போக since I was rectifying my mistakes, I made fewer mistakes, and then yeah, and then I wrote game exam. So it was around 80 to 120, I guess, அந்த ரேஞ்ச்குள்ளே இருக்கும் நான் எழுதின மொத்த டெஸ்ட். ஓகே, ஃபைன். ரொம்ப பேசிட்டு நினைக்கிறேன் கைஸ். கிளாஸ் ஆரம்பிக்கலாமா? ப்ரோ, யூ சே யூ ரைட் சம்மரிஸ் ஃபார் சைட் ஆஃப் ஐ டூ தட் ஃபார் ஃபிசிக்ஸ் அண்ட் கெமிஸ்ட்ரி ஆல்சோ. ஐ டூ தட் ஃபார் கெமிஸ்ட்ரியில். இந்த நோட் போடுறதுக்கு முன்னாடி ஐ ஹேட் என்சிஆர்டியில் இந்த மாதிரி கிராஃப் போட்டு வச்சுருப்பேன். பட் அது வந்து கொஞ்சம் சின்ன இடமா இருந்துச்சு. ஸோ ஐ ரோட் நோட். ஃபிசிக்ஸ் அண்ட் ஆர்கானிக் கெமிஸ்ட்ரி ஐ டென்ட் டூ எனி திங் இந்த மாதிரி நான் எழுதுறேன். பட் ஃபார் பயோ ஐ டிட் திஸ். I wrote summaries inside. It was really helpful. அவங்களே இந்த இடம் கொடுத்துருக்காங்க. and writing that helped me, saved me a lot of time. Startingly, it is obviously time consuming எழுதுறது. But when you look at stuff, okay, in the longer run, போக போக to revise the entire page, நீ அதை பார்த்தா போதும், அதுலேருந்து you will be able to connect the dots. Okay, இது கூட this will fill this void, this will fill this இந்த space இது வரும், you would know, and that saves you a lot of time during revision. So yeah, I didn't do that for physics and chemistry. No. I got 690 in NEET. Bro, can you please write down the books? Please write down the books for physics, chemistry, and bio you used. Okay, fine. Okay, for biology, you want me to write it down, but okay, fine. For biology, NCERT. For chemistry, I use my institution or material and then NCERT. Physics ke full material da. NCERT for organic chemistry full NCERT மட்டும் தான் படிச்சேன். Obviously organic and inorganic. ஏன்னா NCERT you don't have that many questions to solve in physical chemistry. So for MCQs நான் material யூஸ் பண்ண, but still NCERT படிச்சு it's fine for chemistry, entire chemistry. It works. Physics I did this. I studied NCERT once. Okay, and then for physics I solved a few questions from previous year JEE exam oda questions. It's available. நீங்கள் போய் பார்த்தீங்கன்னா, if you search it online, you will get a lot of questions. Previous year questions of JEE mains ஓடது, not advanced, from 2022 to 2025. இப்போ 2026 ஜான் ஷிஃப்ட் நடந்திருக்கும். அதோட பேப்பர்ஸும் பாருங்கள். பிகாஸ் ஃப்ரம் 2022 இட் ஹேட் பீன் கொஞ்சம் நீட்டோட கொஞ்சம் மேலே இருக்கும். But once you solve it, you'll have a better understanding of the concept. Okay, it really helps. Practice books ku I didn't have any practice books special. நான் வந்து நிறையா ஃப்ரீ சோர்ஸஸ் ஆன்லைனில் இருக்கும். ஏதாவது I'll be searching for mock test, அங்கே இருக்கா இது it's present. If you want though, we have mock tests in our SNG app. We have test series 15 full syllabus tests இருக்கு. I took questions for physics. Okay, I try to include as many good questions as possible. Obviously JEE mains level, because once you solve those questions, guys, really they are so lovely that you will have a pakka understanding of that concept. Okay, sometime NEET 2025 was one such paper. It was super difficult. Okay, it was super lengthy, but time constraint, you were not able to solve, but the questions are really nice. இதுலையும் I try to have the same thing. It's available in the Play Store if you want, go check it out. 15 papers, and then you have chapter wise mock tests இருக்கு. And then mock testல வந்து you have 45 questions for each chapter. I took for physics அதுக்கும். And then you have unit tests. 11th entire 11th நான் 3 டெஸ்ட்டாக பிரிச்சிட்டேன். 12th entire 12th 3 டெஸ்ட்டாக பிரிச்சிட்டேன். That's also there. So yeah, if you want, go check it out. Yeah. Yeah. Ramandev. Okay, thank you. Okay, guys. அவ்வளோதானா? You have around, you have less than 2 months. உங்கள் ப்ரிப்ரேஷன் நீட் எக்ஸாமுக்கு. How are you all feeling? Hi, Safura. Class hasn't started yet. Yeah. Sorry guys, I'm a little bit sick. Can I prepare 11th book NCERT also? 45, around 45 days. Pragdish, புரியல Pragdish. You're asking me if you could complete 11th syllabus in 45 days. If you think you can do it, then you can. கண்டிப்பா முடியும். Okay. Okay. So guys, நான் ஸ்டார்ட் பண்ணுறேன் ப்ரோ. நியூவாக ஸ்டார்ட் பண்ணுறேன். யூ ஆர் ரைட்டிங் எக்ஸாம் இந்த வருஷமா இல்லை அடுத்த வருஷமா? 2026. Okay, you don't have 45 days. When you have 45 days or 30, you have 60 days கொஞ்சம் கீழே இருக்கு. 53 days. If you are writing the examination in the வருஷம், I suggest you to focus on both 11th and 12th. Okay, because 2026, yeah, focus on both 11th and 12th. Because you have 50% 11th and 50% 12th. So, studying புதுசா வந்து yesterday after board exam. Okay. So if you are thorough with 12th now, don't put your time in studying 11th. Rather, கொஞ்சம் கொஞ்சமாக படித்து start solving questions. Okay. நிறைய questions solve பண்ணுங்க. Because in the time, the only thing you're supposed to do is practice. You have to solve more questions. Okay, so that on the day of examination you will be able to solve it easier. 2, solve with a timer. Okay, 3 hours you try to solve the entire paper. And the time constraint oda and the pressure la, along with and the pressure la solve panna, get yourself used to it. அப்படி பண்ண தான் வந்து exam, on the day of examination you won't feel any difficulty. Okay, that's really good, Safura. You scored 671 marks. Round of applause, guys. Well, physics mark lower இருக்கு. எவ்வளோ இருந்துச்சு? எவ்வளோ physics mark உங்களுது? Subject wise சொல்ல முடியுங்களா? 11th syllabus questions என்ன பண்ணணும்? அதான் சொன்னேன். As I told already, fluctuations will be there. Okay, என்னோட கிராண்ட் டெஸ்டோட ஹையஸ்ட் ஃபிசிக்ஸ் மார்க்ஸ் வந்து 175, லோவஸ்ட் வந்து 121. ஓகே, 121 yeah, around 120 தான். Okay, I don't know how I still remember all those, but அந்த ஒரு பேப்பர் அப்படி தான் போச்சு. இட் வாஸ் சூப்பர் டிஃபிகல்ட் ஃபார் மீ. ஏன்னா நான் வந்து கொஞ்சம் மிஸ்டேக் பண்ணிட்டேன். நாட் having a conceptual understanding, rather I spent a lot of time in bionic, so I didn't have enough time. ஸோ அந்த டைம் எல்லாம் மேனேஜ் பண்ண நீங்கள் டைம் மேனேஜ்மெண்ட் பிரச்சனையாக இருந்துச்சுன்னா try something different next exam and get used to it and use the same thing in the final exam as well. If it was conceptual based now, since you're scoring already pretty good, 671 is good, try to rectify your mistakes. Okay, mistake rectify பண்ணிட்டு அடுத்த எக்ஸாமில் கண்டிப்பாக இம்ப்ரூவ் ஆயிரும். Even you rectify your mistakes and understand why you are doing this wrong, I think 90% of the problem is solved அங்கேயே. அதுக்கப்புறம் if you are still not able to get it, 100% அந்த அதுலேருந்து if you shouldn't make mistake இதுக்கப்புறம் அப்போ அந்த மாதிரி if you want to get into that state of understanding na, since you don't have time இப்போ, but still you could solve the questions extra. You could practice more questions from the similar topic, from the same topic which you made mistake from. Okay, tips for mechanics anna. Okay, tips for mechanics. I love mechanics. Okay, basically I really love it. Okay, so mechanics வந்து it's see இப்போ 12th syllabus if எடுத்துட்டீங்கன்னா you have atoms, nuclei, dual nature. At least you can actually feel you have some stuffs which are going on with that. Atoms, nuclei எல்லாம் பார்க்கவே முடியாது. Okay, wave optics and ray optics, okay, fine. Magnetism, electricity and all, it's something you can't see. Okay, flow, electric potential ஆகட்டும், flow of current ஆகட்டும், you can't see magnetic. Okay, you can have a physical representation, but still you have never tried all those stuff in your life. Most of people they don't have kept an electric field or magnet வச்சு சுத்தில பார்த்திருக்க மாட்டாங்க. Okay, but what you would have seen, okay, what everyone would have seen in their lives, everything is in mechanics. Okay, so when you feel கொஞ்சம் கஷ்டமா இருக்கு அந்த மாதிரி if you feel it's difficult, try to imagine stuff in your real life. Okay, see, there is a riverboat question. Okay, when you have stream already going on and then you are moving through, okay, across a போகணும், shortest distance ல போகணும், shortest time ல போகணும், எந்த மாதிரி angle ல போனா I will be able to reach there. Everyone, I've seen it. Okay, I've seen it in my village kita somewhere. I saw this thing happening in my 6th grade. Okay, you can actually imagine so many stuff when you say ballistic pendulum. அதில் வந்து you have say a bullet, that's to find the velocity of the bullet. Okay, shoot பண்ணுற, it goes to some extent, there is some potential kinetic energy in the பக்கம், then it converts into potential energy when it reaches the highest point. It's all around you. Okay, unlike medicine which is inside whatever is happening, it's in front of your eyes. So try to imagine it gets easier for you. Okay, it will definitely get easier. எனக்கு ஸ்டார்டிங்கில் it was கொஞ்சம் கஷ்டம், but when I started imagining stuffs like this, okay, because thermodynamics, you can't see a isothermal process. Okay, you don't have ideal stuffs in real life. Okay, all those formulas won't be applicable. Even though mechanics have, okay, நிறைய limitations இருக்கு, it's not accurate, but still whatever you're carrying, even though it's not accurate, but still you can do stuff with that. Okay, fluid mechanics ல பார்த்தீங்கன்னா terminal velocity, lovely concept. If it doesn't exist, if water droplets from the clouds didn't have terminal velocity, that means it would have hurted us so bad when raindrops fall on us. Okay, it's all around you. So try to that's what the first chapter says, physics is the study of nature. Okay, so yeah, enjoy the subject. You'll definitely get well with mechanics. Yeah, because I could tell you study this formula, I could tell you study that formula, but in the end it depends on is how much you imagine stuffs in mechanics. Okay, so yeah, try doing that. If it doesn't work, come and ask me the same note again. Okay, and I have inconsistent procrastination problem now. I'm scoring good in all the subjects except yeah, try Mrinali, try this. Okay, mechanics la வந்து imagine stuff and try solving questions, okay? You'll fall in love with it. அதையும் தாண்டி I suggest you to solve questions from previous JEE mains, okay? The questions are really good. நீங்கள் அதை சால்வ் பண்ணி பாருங்கள். From 2022 இல்லை 2023 24 25 3 years, you just have a look and solve it, okay? I'm pretty sure you will have a good conceptual understanding, because conceptual understanding illadaal dhaan there are mistakes, okay? So when you are good at your concepts, you will be able to solve them correct. Which year you're studying? And bro, for physics, for revising physics, can I do it by solving model questions again? It's good up to some extent. You can solve கொஞ்சமா, பட் உங்களுக்கு ஏற்கனவே அந்த ஆன்சர்ஸ் தெரியும் இன்னும் பட்சத்தில் இட்ஸ் நாட் ரெக்கமெண்டபிள். பிகாஸ் இப்போ நான் ஃபஸ்ட் இயர் 11th ஸ்டாண்டர்ட் படிக்கும்போது ஐ சால்வ் இட், அண்ட் 12th ரிவிஷன் அப்போது நான் திருப்பி சால்வ் பண்ணுறேன்னா அப்போது இட்ஸ் அட்வைசபிள். பட் when you have solved it இப்போ தான் few months back and திருப்பி நீ சால்வ் பண்ணுற, உங்களுக்கு கொஞ்சம் ஞாபகம் இருக்குன்னா there is no point, okay? நீங்கள் வந்து கொஞ்சம் சர்க்கிள் பண்ணி வச்சுக்கோங்க சால்வ் பண்ண. திஸ் மாடல் ஆஃப் கொஷின் வந்து இட்ஸ் கொஞ்சம் டிஃபிகல்ட்டாக இருக்குது. ஐ ஃபெல்ட் இட் வாஸ் டிஃபிகல்ட் when I first solved it, so I have to solve it again. ஏன் அப்போது தான் வந்து யூ வில் ஹாவ் அந்த கான்செப்டோட அண்டர்ஸ்டாண்டிங் உங்களுக்கு அப்போ இருக்கும், ஓகே? அண்ட் இட் வில் ரிட்டைன் as well. Bio 350, chemistry 168, physics 153. Okay. Okay, physics 153. It will get better. Safura, just error correction மட்டும் பண்ணிட்டே இருங்க. Your marks will definitely improve. It's already 671 is actually good. And still, if you want to improve now, try not making the errors again, okay? நீங்கள் சின்ன பாயிண்ட்ஸ் தான் வந்து மிஸ் ஆகிருப்பீங்க. இப்போ இஃப் இந்த ஸ்டேட்டில் இருக்கும்போது ஒரு சாப்டரில் you would have missed few points, you would have skipped கொஞ்சமாக. அதுலேருந்து இஃப் கொஷின்ஸ் கம்னா யூ வில் நாட் பி ஏபிள் டு ஆன்சர். இதெல்லாம் இல்லைனா கான்செப்ட் தப்பாக அப்ளை பண்ணியிருப்பீங்க. ஸோ ஜஸ்ட் ட்ரை டு sort it out. போக you will obviously get 180 if you rectified your mistakes and அந்த சின்ன கேப்ஸ் எல்லாம் க்ளோஸ் பண்ணிங்களே போதும், ஓகே? Okay, thank you. All right, too much talking. let's start the class, okay? Because since this chapter is super simple, okay? Kinetic theory of gases is super simple. I could teach you in like 2 hours or 1.5 hours முடிச்சிடலாம். But your exams are approaching, and as a mentor here, a brother, okay, a senior, I would like to help you out in this journey. So yeah, now on the NEET 2024 batch, bro. All right, so yeah, done. If you have any doubts, class endல கேளுங்க. So this is, for those who don't know me, I am Rehan from second year MBBS from Madras Medical College. This is our Vidamuyarchi team. Every day at 6:30 PM we will be live taking classes for you. Yeah. All right. Today's class, kinetic theory of gases. இப்போ அதில் இனிஷியல் மிஸ் ஆகிருக்கு, 10th மார்க் ஷீட்டில் இனிஷியல் இருக்குது. இதுக்கு எக்ஸாம் எழுத ப்ராப்ளம் வருமா? ப்ரோ முடிஞ்சால் சேஞ்ச் பண்ணிடுங்க. சேஞ்ச் பண்ணிடுங்க. பட் யூஸ்வலாக பிரச்சனை வராதுன்னு நினைக்கிறேன். பட் ட்ரை டு சேஞ்ச் இட், ஓகே? Because documents ஒழுங்காக இல்லாமல், my friend who wrote examination last year, he would have gotten a private college seat at least, okay. But அது என்னாச்சு, his birth certificate or a document, something was wrong in his birth certificate. They forgot to change it. And NTA, I mean, counseling, okay, teen medical counseling, அவங்க வந்து கொடுத்துருக்காங்க, ஐ மீன் மெயில் அனுப்பிச்சிருக்காங்க, இது மாதிரி செக் பண்ணுங்கள், திஸ் இஸ் ராங் அப்படின்ட்டு. they had a few they intimated them, but அவன் பார்க்கல, he thought it was right. அதுக்கப்புறம் அந்த என்டையர் ஷீட் வரும்போது his name was not included, okay, கவுன்சிலிங் முடிஞ்சு. ஸோ யா, ப்ளீஸ் செக் இட் அவுட். அது இட்ஸ் கொஞ்சம் சீரியஸான விஷயந்தான், ஓகே. ஆல் ரைட், கைனடிக் தியரி ஆஃப் கேஸஸ் பக்கா. We start with Boyle's law, okay. Boyle's law, so everyone knows it from chemistry, this thing, okay. Okay bro, thanks. Okay, thank you. All right. Boyle's law, okay. What does Boyle's law say? Very simple, very simple, okay. At constant temperature, pressure is inversely proportional to volume. அவ்வளோதான், இந்த ஸ்டேட்மெண்ட்டோட முடிஞ்சு இந்த லா. அடுத்த லா போகலாம், ஓகே. அட் கான்ஸ்டன்ட் டெம்பரேச்சர் ப்ரெஷர் இஸ் இன்வெர்ஸ்லி ப்ரொபோர்ஷனல் டு வால்யூம், ஓகே. அதாவது லாஸ்ட் கிளாஸ் ஐ டிஸ்கஸ் அபவுட் thermodynamics, ஓகே. thermal ப்ராப்பர்ட்டிஸ் ஆஃப் மேட்டர்லையும் வரும், பட் thermodynamicsல we saw that isothermal process, அதில் வந்து thermal, அதில் வந்து it's isothermal, அதாவது temperature is constant. Boyle's law ஓட curves, graphs plot பண்ணும்போது we call those lines as isotherms because they are isothermal, okay, because temperature change ஆகல. Fine, okay. All right, so அப்போனா என்ன? So when P is the inversely proportional to V, we can write PV is equal to constant. Let's try to feel this, okay. When you have a closed chamber in your control, okay, உங்கள் ஹேண்ட்ஸ் தான் அதோட பவுண்ட்ரி. மேலே வந்து there are other some other things, உங்கள் கையும் அதோட ஒரு part of its boundary, and you are squeezing it. When you squeeze it, okay, you're applying pressure to it. When you apply pressure, okay, the volume of the container குறையுமா? It decreases, okay, obviously. See, when you have இவ்வளோ பெரிய container and then you have இவ்வளோ பெரிய container, still the gas inside is same, okay. The mass of the gas now is மாத்தல, okay. So the substance present inside is present inside now, but when I pressurize it, okay, when I add some pressure, its volume decreases, okay. This is your so அப்போனா என்ன? When adding pressure increases, volume decreases. P is inversely proportional to V, okay. This is your Boyle's law. Let's plot graphs for it. எல்லாருக்குமே தெரியும் இன்வெர்ஸ் ப்ரொபோர்ஷனல் கிராஃப் வந்து இப்படி இருக்கும்னு, கரெக்டா? Yeah, so this is your at temperature T, where T is constant, there is no change in the temperature, okay. Fine, all right. Now I'm asking you one question, okay. say I have a PV graph. I plotted rend curves. Okay, it has temperature T1, this has temperature T2. Okay, temperature T1, temperature T2 இருக்கு. Which one is right? எது correct? Let me know in the comments. சீக்கிரம். Okay, I'll tell you what concepting is. See, imagine same the container inside. When you apply heat, when you give heat energy, the container on the say anything when you apply heat, okay, thermal properties is not yet over, but you have seen, okay, நீ heat apply பண்ணும்போது everything expands, okay, everything expands at some rate. கொஞ்சமாக இன்க்ரீஸ் ஆகும், அதிகமாக இருக்கும், இன்க்ரீஸ் ஆகும். And the expansion for gases is high. Fine, okay, so okay, done. Now when gases expand, okay, a container la நீ heat apply பண்ற, gases are expanding. When they expand, and the molecules எல்லாம், when you imagine, those molecules will go already, which they will be hitting the wall, okay, causing the pressure. When you increase the temperature, they will wobble even more, they'll move even faster, they'll hit the wall of the container even with more momentum, okay. So there is more change in momentum, there is more force applied on the container, so more will be the pressure. Did you get my point? So more pressure, okay, more will be the volume, so the temperature is higher, okay. So my T2 is greater than T1. This is the only question they can ask from this topic. இதுக்கப்புறம் they can ask direct numericals, okay, but அது நமக்கு இப்போ தேவையில்லை. எப்படி கேட்பாங்கன்னா, numericals say the pressure of the gas in an isothermal process, okay, initial pressure வந்து it was 5 atm, volume வந்து 1 liter வச்சுக்கோ, finally it was 5 atm 1 liter, finally it became 3 atm, okay, அதோட வால்யூம் சேஞ்ச் எவ்வளோன்னு கேட்குறாங்க. It will be 5/3, final volume 5/3 liters, okay. ஸோ இந்த மாதிரி பேசிக் நியூமரிக்கல்ஸ் வரும். and then you'll have this இந்த மாதிரி questions. These are இந்த இண்டிவிஜுவல் பிளாட்ஸும் வந்து உன்னோட ஐசோதர்ம்ஸ். Okay, these are my isotherms, and it's in same temperature. All right, clear? பக்காவா? Okay, clear. All right. So I'll go to next topic. Okay. When one topic over, just give me a thumbs up because I just want to know how it was. Okay. Thank you. We'll go to the next topic. Okay. Okay. I'll have few more graphs. Okay. This is Boyle's law. P T graph, V T graph, where if pressure increases, the volume decreases. Okay. Straight line. This is also your Boyle's law in our set of possible questions. Fine. Okay. All right. Now the same thing for ideal gas and real gas. Okay. An ideal gas is something. Okay. Basically, physics in our entire 11th and 12th, in our UG level, I mean, in 11th and 12th, okay, high school level, we assume stuffs, okay. There are few radical assumptions which are not real, okay. We call them as ideal. It's not really, you can't have something ideal. Human beings are imperfect, so is everything here. Our assumptions are imperfect as well. Basically, இப்போ நீங்கள் fluids எடுத்தீங்கன்னா you have an ideal fluid where it will have always laminar flow, it won't have any viscosity and all, no interaction all. The same thing here, okay. For an ideal gas, it'll follow all these law, and also this ideal gas will have no interaction with the molecules, and okay, within molecules they'll have forces, and then it should obey gas laws. Done. Okay, so I will draw here a few work graph, same PV graph tha, but for an ideal gas and a real gas. Okay, when you take a pressure volume graph for an ideal gas, this is your PV, okay, and when you take the same thing, this is your isotherm of ideal gas. அதே வந்து அதே டெம்பரேச்சரில் when you plot a graph for a real gas, okay, இந்த dotted line இருக்கு இல்லையா, அது ரியல் கேஸ் தான். So you have an ideal gas, you have real gas. Fine. There is some distance in here. Correct. There is some distance. Okay. Difference இருக்கு அந்த ரெண்டுக்கும். This is a temperature T1. Okay. When I increase the temperature to a temperature to T2 னு வச்சுக்கோ, T2ல வந்து this is my ideal gas curve. and this will be my real gas oda curve. இங்க பாத்தீங்கன்னா the distance, it has reduced, okay, T2 is greater than T1. Now this is what everyone wants to have a good understanding about. Okay, see, basically okay, understand. See, in the chapter la and solving MCQs, you must have good understanding. See, when I have a gas, okay, fine, there are particles inside, fine, paka. அது வந்து in ideal gas, just listen to this carefully. In ideal gas, there are interactions between molecules. Paka, everyone knows this. I mean, there are no interaction between molecules. அதனால தான் வந்து we have a particular isotherm for it at that temperature. Okay. In real gases, there are physical interactions. Okay, I mean, not physical interaction. They may have collisions. Okay, they have collisions. They have electrostatic force of attraction between them. They have nuclear attraction between them. Okay, than nuclear, electrostatic is more pronounced because nuclear is very short length. Okay, so you have nuclear attraction, I mean electrostatic attraction between them. So basically positive of one thing attracts negative of another thing, and then you have conjugation stuffs. Okay, so due to electronegativity, electrons get pulled to one. You have a net positive one atom, a net negative on another atom, which will have another interaction. Fine. In an ideal gas situation, this doesn't happen. Okay, none of this takes place. Okay, there is no interaction between molecules. Okay, say I heat my set of gas. Okay, gas அதை நான் heat பண்றேன். When I heat them, I'm giving it kinetic energy. Okay, so they'll start moving very rapidly. Okay, fine. When they move rapidly, okay, they move poga poga, the interaction between molecules becomes insignificant. See, when you're moving, see, when you're static, okay, there will be some interaction, some pull, okay, everything. But I'm giving it energy so that it won't have anything, okay, of that interaction. So basically, when I heat it up, okay, my gases, okay, my gas becomes more ideal. அதனால தான் வந்து there is this less difference in the plots than that of this one. ஏன்னா இதோட temperature is higher. So more the temperature, lesser the interaction between the molecules, and closer it becomes to becoming an ideal gas. Pakka? Clear? Okay. All right. So yeah, this is your Boyle's law. But this entire concept, I'm going to repeat again in Charles' law. Okay, Charles' law is nothing but when you have constant pressure, or volume is volume is proportional to temperature. Okay. At constant pressure. At constant pressure, volume is proportional to temperature. Okay, one thing I want to know, I want to write it here. I'm ready. PV is constant now. I can write P1 V1 equals to P2 V2. Okay. Okay, done. Volume is proportional to temperature at constant pressure. Pakka? This is what my Charles law says. இப்போ I have gave you an idea of a small concept அங்க in the previous thing. where higher the temperature, the more ideal my gas becomes. Okay, here I have something else. Okay, these both together will help us in reaching ideality to some extent. Okay, let's just listen. So volume is proportional to temperature. Now we can write V1 by T1 equals to V2 by T2 at constant pressure. Fine. This is clear for everyone. Paka. Okay. So the graph I plot. So since they are proportional, it will be a straight line. So this is my volume. This is my temperature. It's a straight line. Okay. Okay. I can't do this yet. Okay. Now. Here. Okay. I'll make it now. Yeah. I got everything. Now, I plotted with volume and temperature. I mean volume and pressure graph. Volume and temperature graph. Volume and pressure graph and volume and temperature graph. Okay. Oh no. Temperature and pressure graph. Okay, ரெண்டு graph இருக்கு. We know that when volume increases, okay, what? My volume is proportional to temperature at constant pressure. Okay. So if my volume increases, my temperature also increases. At constant, remember, at constant pressure. Okay. Okay. This is what my Charles law says. Okay. Same. A real gas, ideal gas thing for the same thing. At what pressure? Okay. Before that, one more thing. Now you have to compare between two stuffs. Okay. Rend graphs I'll compare. I'll do comparison. Okay. I am going to compare between two graphs. Okay. V T. This is pressure P1. This is pressure P2. Which one is right? P1 is greater than P2 or P2 is greater than P1. In the logic which if you are not able to answer in the examination, in the exam, if you are not able to answer using logic, there is an ideal gas equation which will come up later. Okay, அது நான் சொல்றேன் இப்பவே சொல்லிடுறேன். Okay, it's fine. I think it will be fine இங்க. T2 is greater than T1 ஏன்னா it's more higher சொல்றேன். ஏன்னா if you see P1, we have an equation, ideal gas equation. அதில் வந்து it states PV is equal to nRT. Okay, nRT. Okay, in the case the graph is dp by dv. Yeah. Okay. All right. இது வந்து it will be written as minus p by v. Simply to have that form. Okay, அந்த form இருக்கு. I just multiply with v by v இங்க. So v square by v square. So இங்க வந்து it will become p by v is proportional to t. So அதே வந்து it becomes minus na, it becomes inversely proportional. So that's the concept here. அதே வந்து if I want to apply it இங்க see Charles lawல V PV is equals to nRT. Okay, see here இங்க வந்து it's V by T. V by T is my slope. Okay, so V by T is equal to R n by P. Okay, so my slope inga is inversely proportional to P. I mean inversely proportional to T. Hope you can see it. So when it's inversely proportional to P, okay, so இப்போ இது higher slope na, it has lesser pressure. It has lesser slope na, it has higher pressure. Okay, so my P2 greater than P1. Are you clear? Yeah, Safra is right. Okay. This is my okay. Yeah, okay. Okay, paka. This is my real ideal gas for the okay. Ideal gas. And I have real gas. Okay. When நான் அதை plot பண்ணும்போது it was somewhere in the way. Okay. When you observe here, the ideal graph oda, I mean ideal gas oda graph, it starts to coincide with the real gas at higher temperature. Correct? For ideality, the temperature has to be increased. Okay, this is how the graph will be. Now, for okay, the concept of ideal gas is nothing but you should have no interaction between molecules. Oh, it's okay. Molecules only interaction required. So basically, when you don't have when you don't want to have interaction between molecules, one you increase the temperature. Adala there will be more kinetic energy. It will move away, and yeah, paka. 1. 2, you could reduce the pressure. Just imagine container in front of you. Reducing pressure is nothing but moving your hand away. Okay, when you move your hand away, there will be more space. So molecules, when they occupy a larger space, okay, the distances between them will increase. When you apply for pressure, they tend to collide with each other. They tend to interact more. But when you reduce the pressure, okay, when you reduce the pressure, they just relax. Okay, they just move freely. When they move freely, the interaction between them reduces. That brings us to ideality again. Okay, so ideal gas you increase the temperature. High temperature I mean real gas ideal gas oda properties varakku you increase the temperature and you reduce the pressure. Okay, these are the two things important. I hope this is clear. All right. Okay. Now I have a question for you. Say I have a 4 mole gas. 4 moles of 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 4 moles an ideal gas என்கிட்ட இருக்கு 4 moles of an ideal gas பக்கா இந்த ஐடியல் ஓகே ஒரே நிமிஷம் I have 4 moles of an ideal gas. Okay, 4 moles of an ideal gas. இந்த கேஸை வந்து at constant pressure, okay, Charles law, it's expanded, okay, from V to 2V. Okay, fine. Initial temperature is 0 degrees Celsius. Okay, final temperature கண்டுபிடிக்கும். Okay, very easy. V1 by T1 equals to V2 by T2. Correct? This is your thing. Okay. Initial volume was V. Say in initial temperature 0 degrees Celsius. See, I told you in last class only. Temperature vandale you have to convert into Kelvin. Okay, say check if it's Kelvin or not. So you can't write V by 0 in pota, it will become infinity. Okay, I mean not defined aircon, so my entire equation will be wrong. I have to convert it into Kelvin. Okay, Kelvin scale. So 0 degrees Celsius is 273 Kelvin. 273 degree Kelvin, this will be equal to 2V by T2. Cancel. My T2 will be 546 degree Kelvin. Correct? It can be written as 273 degree Celsius. Okay, this is the answer. Okay. Now when you have questions in the Kelvin to Celsius on the you have to subtract it. I mean subtract 273 or add 273 and the மாதிரி இருக்கும். This is your Kelvin scale to Celsius scale. பக்கா? Okay. 546.3 Kelvin or okay, this is basic question. I'll give you an understanding of this one. Okay. 273 degree Kelvin, I mean 273 degrees Celsius increase ஆகும்போது my, okay, from 0 degree to 273 degree Celsius இங்க இந்த questionல, okay, 0 degree Celsius இன்னும் 273 போகும்போது the volume என்னாச்சு, it became from V to 2V. Okay, the increase in volume is V. Okay, so I'll compare it. So for 273 degree Celsius increase in temperature in Celsius scale, the change in volume is V. So for every 1 degree Celsius change, my change in volume will be V by 273. Correct? For every 1 degree change in Celsius. Okay. Now I'll derive a simple equation here. Now this is your thing. Okay, this is your thing. If I'm adding, if the question, say the question comes like there's an increase in temperature of 5 degrees Celsius, just 5 degrees Celsius. Okay, if there's increase in just 5 degrees Celsius, 5 degrees Celsius, what will be the increase in volume when the pressure is kept constant? Okay, 5 degrees Celsius increase, pressure is constant. Okay, volume change. Okay, volume change, pressure is constant, 5 degree increase in Celsius. Okay, now can I rewrite this equation in the mari? My volume at T degree Celsius will be equal to my volume at V naught, my initial volume, plus V by 273. Okay, this is volume increase per degree Celsius into T, which is change in volume, which is increase in temperature. Okay, I can write it. We can't move it. Okay, nice. So in the question lab, if it became from 0 degrees Celsius to 5 degrees Celsius, I can't do this. I can't write this. Okay. Because the calculation becomes more difficult, but still it's derived from this equation. So initial volume is V by, initial volume is V. Volume increases V by 273 per degree Celsius into 5 is equal to my volume at 5 degrees Celsius. This is volume at 0 degrees Celsius. I hope this is clear. Paka, clear. Clear. Just let me know in the comments. Come on. Okay, no response. Okay. Thank you. Safara. All right. Now, let's plot this entire equation in a graph. Okay. Everything. Let's put everything in a graph at this point. Okay. A graph at the graph. Okay, KTG is a very simple chapter. Okay. Just konjo complicated. I'll make it easier. You have mean free path, and then kinetic theory of gases. You have degrees of freedom. Degrees of freedom, I thought it in thermodynamics already. I'll repeat it again. Don't worry. Okay. So basically, when you have this, okay, Kelvin to Celsius scale, scale, your equation goes like V at T degree Celsius equals to V naught plus V by 273 times change in temperature. This is my equation. Okay. This is in the form of y equals mx plus c. Okay. This is my mx. This is my c. So this is my v. This is t. Mx x coordinate I'm using temperature. So this comes into x coordinate. This is my c, constant. So the graph for Celsius in the Maripo. This will be my V naught. The slope will be V naught by 273. And yeah, this is my y-intercept. Okay. Clear. This is how the graph goes. Paka. Okay. All right. Now just have a look at this. Avogadro's hypothesis. Okay. Avogadro's hypothesis. Beautiful. Okay. It goes like at constant pressure and at constant temperature. Okay. Constant pressure and constant temperature. the volume at same volume, I mean, okay, let me phrase it properly. Okay, I'll write it down first. At constant temperature and pressure, okay, equal volume of gases have equal number of molecules. Excuse me. Okay. Okay. This is what Avogadro's law says. Okay. Basically. So what is this all about? Say I have 5 containers. Okay, 5. I'll add 3 containers. Okay. And these containers are kept at temperature T and pressure P constant. Okay, containers are kept in the mari. Say I'm having, say, hydrogen H2. Say I'm having carbon dioxide inga. Say I'm having oxygen inga. Idila 100 ml. Idila 100 ml. Idila 100 ml. Okay. So when I see the number of molecules in each container, the number of molecules, say that it's X in hydrogen container, it will be X in CO2 container, and it will be X in O2 container as well. Why is it so? Why is it so? To have understand okay, Avogadro's law proper, okay, at standard temperature and pressure, okay, STP conditions, it states that 1 mole of gas occupies 22.4 liters of volume. Okay, 1 mole of gas occupies 22.4 liters of volume. To have a great understanding, it's simple. Say I am having 100 molecules, okay, 100 air molecules. Air on the it just fills space, okay, it just fills space. Simple. So when you have 100 molecules of something, it'll occupy some space, okay. Their intermolecular distances are also obviously high. Let's say that on the 100 molecules, they're of konjam perisa. Those same 100 molecules konjam little bigger, they still tend to occupy the same space. And even bigger, say SO4, even bigger, still they tend to occupy the same space. Okay, it's like having 100 seatings, okay, 100 seatings in a classroom, and providing 100 students to sit in it. Okay, let them be pre-KG students, okay, preschool, nursery students. 100 students in the 100 places occupy பண்ணுவாங்க. Let them be high school students, let them be undergraduates, postgraduates, they'll occupy the same number of seats. Okay, obviously. Say high school la they lost I mean or 5 members didn't come, so they'll occupy only 95 seats, correct? Remaining 5 seats will be empty. Even though when you collectively take the mass of the high schoolers, when compare it with the nursery students, okay, their mass will be higher. They're obviously taller and bigger, okay. Same case here. So where is bigger, okay. Still, only 100 seats are available, and you have 100 molecules for it. So they'll occupy all the 100 seats. Paka. This is the basic thing of Avogadro's hypothesis. Okay, I don't want to get into this. Okay, podum. Yeah. Okay. Now when there are different volumes, okay. I hope you understood with that analogy. Put a thumbs up on the chat. Mm, okay. Thank you. Okay, paka. Three similar containers. I'm having 50 ml இதுல 20 ml இதுல 100 ml இதுல of O2, CO2 and helium. Okay. Now say helium or 100 ml of gas there are X molecules. அப்போனா the number of molecules in CO2 will be X by 5. The number of molecules in O2 will be X by 2. This is what I wanted you to know. Okay, this is your Avogadro's hypothesis. Okay. Next, this is your ideal gas equation. Ideal gas equation, very simple. It includes everything. All those laws. It's here. PV is equal to nRT. So where P is your pressure, V is your volume, R is your gas constant, universal gas constant, and T is your temperature. Okay, fine. This is your ideal equation. Either based பண்ணி you can solve every question. Almost every law whatever you studied. See, PV is proportional to T when I mean P is inversely proportional to V when temperature is constant. You can take this as constant, and then they will be in inverse relation. You take volume as constant, they will be in direct relation. You take pressure as constant, they will be in direct relation. So yeah, basically everything can be derived from this one equation. This is your ideal gas equation. Okay, Paka. You can rewrite this konjama. Okay, where n is number of moles are. Okay, PV is equal to n can be written as mass of substance by molar mass into R into T. Okay, this mass of substance can go down. So P into V by M equal to R by molecular mass into T. I can write it in this way. இதை rewrite பண்ணனா P capital M divided by RT is equals to small m by V. Are you clear with this? Okay, Paka, done. Okay, now what is M by V? M by V is nothing but your density. So density can be written as pressure into molecular mass of substance divided by universal gas constant into temperature equals to density of the entire gas. Fine. Now I want density of an individual molecule. How do I find it? This is what? Molar mass. Molar mass can be written as pressure into molecular mass into Avogadro's number. Correct? Molecular mass into Avogadro's number. That is the number of molecules. And the molecule mass. Okay. That K divided by R into T. Okay. This is my density again. So this N by A, Avogadro's number, it can come here down. Okay. Beautiful. So it will be P into M, which is molecular mass or individual molecular mass divided by K into temperature T. This is my density. Paka, clear? Okay, fine. There is a question in NEET 2026. I mean NEET, not 2026, 2016. There is this meme going on. We are back in 2026. I mean 2016. 2016 NEET lab. There is this question. Okay. The question goes like, you have an ideal gas occupying a volume of V at a pressure of P at a temperature of T. And the molecular mass, okay, this M is the molecular mass. Right? Find the density of the gas. This is the molecular mass, M. So density of the gas is nothing but P capital M divided by RT. Correct? I mean P. Here, since small m is the molecular mass, find density. Basic question. You know, they can't ask anything more than this. Okay, this basic stuff. All of that. Paka. Paka, people. Yeah. Thumbs up in the chat box. Thank you, Safura. Only one person who actually responds. Thank you so much. Okay. Thank you. Yeah. All right. Now I have one more question. One beautiful question. It's a beautiful concept as well. Okay. This exact thing, exact same ideal gas equation thing. We have two vessels. Two vessel separately with two different ideal gases. Two vessel and ideal gas. The temperatures are same. T is same. And ideal gas one on the A, no ideal gas B. Okay. Pressure of A the pressure is twice that of B. So it's P by 2. Okay, since okay, pressure of A, this thing twice that of B. Temperature is same. Okay, fine. Now it's found that density of A is 1.5 times that of B. அப்போ B ஓட density வந்து D னா A ஓட density வந்து 1.5 D. Okay. these are all the things they have given. So நம்ம வந்து என்ன கண்டுபிடிக்கணும்னா we are supposed to find ratio of molecular masses of A and B. Okay, fine. Okay. What is density? Direct formula, or it's why is it cross standard? Okay. I think it's fine. Okay, so the formula for density is P M by RT. This is the density formula. Okay, where M is the molecular mass. Fine. இப்போ வந்து I'm finding the ratio of, say, ratio of dA by dV. So this is the answer in red. Okay, density, pressure of A, molecular mass of A divided by R into temperature of A divided by pressure of B into molecular mass of B divided by R into temperature of B. Pretty simple question. So dA by dB we know it's 3 by 2. 3 by 2 is equal to pressure of A is nothing but P. Let's take it as 2P. It's complicated பண்ணிட்டு they gave it as P. Okay, let's take it as 2P. 2P molecular mass of A is what you're supposed to find divided by R into temperature is ரெண்டுக்கும் same, P into molecular mass of B divided by R into T. Paka. RT cancel, P cancel, MA by MB will be equal to 3 by 4. Okay, fine. All right. Paka. Okay, density discuss பண்ணிட்டேன். let's density அங்க டிஸ்கஸ் பண்ணியாச்சு. இது ஃபுல்லா டென்சிட்டி பேஸ் பண்ணி தான் இருந்துச்சு. யா okay, all right. So we have a gas at 10 degrees Celsius. அதோட at 10 degrees Celsius an ideal gas. பக்கா. அதோட density divided by அதோட pressure is x வச்சுக்கோங்க. ஓகே, அப்போ 110 டிகிரி செல்சியஸில் அதோட டென்சிட்டி பை ப்ரெஷர் ஓட வேல்யூ என்னவா இருக்கும்? வெரி சிம்பிள் கொஷின், வெரி ஸ்ட்ரைட் ஃபார்வர்ட் கொஷின். த ஃபார்முலா இஸ் PM by RT. Okay, the only variable steps are P and T. Paka. R and M are constant, so this is D. Let's go. அவன் என்ன சொல்கிறான், density by pressure is constant, so M by RT is equals to density by P. Yeah, initially at 10 degrees Celsius Kelvin மாற்றணும். பக்கா. okay, so the answer goes M divided by R into 10 degrees Celsius na it's 283 degree Kelvin. 283 is equals to X. Let's go. இது வந்து ஃபர்ஸ்ட் இது ஈக்குவேஷன். இதுக்கு வந்து இட் வில் பி m டிவைட் பை RT வந்து T is 110, so it's 383. 383 is equals to say y. Okay, simply divide everything. Okay, we can write 383 into y is equals to 283 into x. Okay, y is equal to 283 into x divided by 383. This is my d by p ratio. Okay, paka. Yes, my d by p ratio. What mistake people do in the question usually 383 இருக்கா, நான் வந்து கெல்வினா மாற்றினேன். கெல்வின் மாற்றாமல் மேலே டேரெக்டாக இங்கே 10 போட்டுப்பாங்க. 283 பதிலாக 10 383 பதிலாக 110 போட்டுருவாங்க. ஸோ தி ஆன்சர் வில் பி 10 by 110 or 1 by 11. Don't do that mistake. Okay, so yeah, thank you so much. Alright, next வந்து we have kinetic theory of gases ஓட ப்ராப்பரான postulates, RMS velocity, mean free path, Maxwell speed distribution, and I will discuss thermal election. I discuss பண்ணிட்டேன், but still those who haven't watched the lecture, I'll teach you degrees of freedom and what it is all about. Okay, paka. Until then, let's take a break for இப்ப time 17. So yeah, let's take a break for 15 minutes. Class resumes at let's round up பண்ணிடலாம். என்ன பண்ணலாம், 15 minutes தான், will be 32 35 8:35. PM. A small break, and then I'll discuss the rest of the entire chapter to you. We'll wrap up with few questions. Okay, mean free path ஆகட்டும், RMS velocity and other velocities as well. I'll discuss everything to you. Okay guys, see you. All right. Okay, it was supposed to be 38. I'm sorry, I was. Okay, done. Did everyone have something? The gapla? Just give me a second. One minute. 1 minute. Yeah, it was just too cold. Okay, fine, paka. All right, guys. We are into the postulates of kinetic theory of gases. Before this, I want to tell you about something a little important in terms of this chapter. Okay, there is something called as mean free path. Okay, okay, not mean free path. Okay, mean free path comes later. You have something called as degree of freedom. I'll give you the feel of what this is. Okay. Okay. What a feel there. Just imagine. I have a single molecule of a gas. Okay, this single molecule has one atom. Okay, it's not diatomic, it's not triatomic. Okay, it's not polyatomic. It has one molecule. Okay, this one molecule of my of gas. Okay, this single molecule can move in three axes. Okay, it can move in x-axis to and fro, y-axis to and fro, and z-axis to and fro. Fine. X, y, and z. In all three directions, it can possess velocity. So in all three directions, it can possess kinetic energy. The degrees of freedom of any molecule of gas is nothing but the number of ways in which it can possess kinetic energy. So I can have kinetic energy மூணு விதத்துல. I can have one in x-axis, I can have one in y-axis, and I can have one in z-axis. Okay, fine. This is your translated kinetic energy. But when you take a diatomic molecule like oxygen, okay, இப்படின்னு வச்சுக்கோ, இந்த மாதிரி இருக்கு. Okay, so basically atoms are small. Okay, we know, but the molecules are pretty comparatively bigger than them. Okay, so when you take this molecule, okay, this can move in three axes. Paka, this can move in y-axis, this can move in x-axis, and this can move in z-axis as well. Okay, all three can take place, and then we know that atoms can rotate. This can rotate as well. Rotate aguma. Even the single molecule, single atom irukradhum vande it will spin around its own axis. But since atomic radii is small, atomic radii is super small, so that it's the moment of inertia காட்டுறேன் உங்களுக்கு என்ன இருக்குன்ட்டு. So moment of inertia I is equal to mr square. Okay, r is already in 10 power minus 16 something. R square will become 10 power minus 32. Super insignificant, we don't have to consider it. So for a single molecule single atomic gases, monoatomic gases, the radius, the moment of inertia is 0 technically. அண்ணா நீங்கள் ஃபர்ஸ்ட் அட்டம்ப்டில் நீட் க்ரியேட் பண்ணிட்டீங்களா அண்ணா? ஆமாம். ஓகே, ஸோ this is basically what it is. Okay, for diatomic molecule, say இது வந்து ஒன்று, it can ரெண்டு molecule, it can spin like this. Okay, one and it can spin like this, correct? And then it can spin around its own axis. Own axis spin பண்ணும்போது again the same thing, the radius is super small. The radius is super small. The radius is super small. Because the radius is super small, I is insignificant. அதனால it will have two rotation kinetic energy, one in the axis லையும் one in the axis லையும். So it has a degree of freedom of 5. This has a degree of freedom of 3. இங்கே இதில் வந்து 5 is nothing but 3 translatory and 2 rotational. Yesterday's thermodynamics lecture I went into it little in depth. Okay, fine. And they have figured it out that each degree of freedom order kinetic energy is nothing but half into k into t. Okay, for one molecule, or it will be half into r into t for 1 mole of gas. Okay, this is your ke per degree of freedom. Okay, basically it. So total kinetic energy will be nothing but degree of freedom F into R by 2 into T. அவ்வளோதான், done, finish. Degree of freedom, this is one சின்ன concept I wanted to tell you. Clear? Yeah, I did clear it in person. Okay, so let's okay. All right. Yeah, let's get into postulates. Thank you guys. போலாமா postulates-குள்ள? Okay, just few stuffs to discuss. Okay, clear? இல்லை இது எனக்கு chat update ஆக மாட்டேதா? There is no one actually responding. இல்லை. Okay, fine. But still, postulates, I'll tell you. Okay, the first postulates of kinetic theory of gases. அதுக்கப்புறம் RMS velocity-குள்ள போயிடலாம். Postulates, blank page here. Okay, what is cases? First one, gases are made up of atoms and molecules. Okay, everyone knows this. Okay, molecules of same gas are identical in shape. and size. It doesn't matter. Everyone knows this, okay? Only few steps are important. Molecules constantly move only in a straight line. This is an assumption. Okay, so இப்போ நான் degrees of freedom discuss பண்ணேன் இல்லையா? So in degrees of freedom, the thing is, yesterday sorry the second half video is not, it keeps getting stuck. Yeah, there was an issue, there was an internet issue, it didn't work. இந்த ஆப்ல வந்து the wait, I'll figure it, the term என்னன்னா, there has to be data transfer from, okay, there has to be data transfer from my streaming software to YouTube, okay? It's supposed to be at 6000 kilobytes or bits per second, okay? ஆனால் நேற்று எனக்கு வந்து 400 ஏதோ இருந்துச்சு. 6000 எங்கே இருக்குது, 400 எங்கே இருக்குது, it kept fluctuating. அதனால தான் the video is not proper, but I explained it. So I'll try to sort that out. எவ்வளோ ப்ராப்பராக இல்லையோ I'll try to somehow re-record or do something, okay? Thank you, Safura. Yeah, because it I don't know what to do yesterday. It was an internet issue. Wi-Fi tha, but still I don't know what happened yesterday. I will try to do something about that. Okay, thank you. All right. So basically, degrees of freedom, if you see, I need but still okay. If you see, a diatomic molecule has 5 degrees of freedom, okay? A triatomic can have 6. Okay, you can spin in all 3 directions and you can still include it. And vibrational, you can add +2 as well. But our assumption is it is moving only in a straight line. So when it moves in a straight line, the degrees of freedom for that will be just 3. Freedom for every molecule. Okay, this is very, very, very important. So no matter what you take, since in the equation we know that kinetic energy is nothing but 1/2 RT for each degree of freedom, and our assumption is that everything moves in a straight line. Apona the kinetic energy of every atom, okay, I mean every gas, it's nothing but 3/2 kT of a molecule, or 3/2 RT of a gas. Okay, paka. All right, next கொஞ்சம் தான் முடிச்சிட்டு போயிடலாம். Okay, our assumptions are collisions. Okay, when these molecules collide with the wall of the container, those collisions are considered to be elastic. Okay, and these collisions now they put pressure, they exert pressure. Okay, and one more thing. So since pressure is exerted by collision, pressure is proportional to number of collisions. Okay, these are all assumptions. Collision ஆறுது, it's elastic நினைக்கிறாங்க. All this. Okay, paka. Now okay, kinetic energy, we saw that kinetic energy is equal to 1/2 kT, okay, for individual molecules, for individual for 1 degree of freedom. So K E is basically 3/2, அதாவது 3 degree of freedomக்கு 3/2 kT for a molecule, or for one mole it's 3/2 RT for 1 mole, or for n moles it's n into 3/2 RT. but என்ன வேணா எடுத்துக்கோங்க, ultimately depends upon only temperature. So yeah, this is our kinetic energy. And also actual volume of individual gases, okay, individual molecules of gases, ஒரு ஆட்டமோட வால்யூம் எடுத்து அந்த வால்யூமை நம்பர் ஆஃப் molecules, number of atoms present கூட if we figure it out, it won't be equal to the number of, it won't be equal to the volume occupied by the entire set of atoms. Okay, so ஒரு கண்டெய்னரில் if you have atoms na, see அந்த 6 atom இருக்கு, they occupy இவ்வளோ இடம், ஓகேவா. பட் if you in practical actual volume of them will be இவ்வளோ தான். Okay, that's the difference with what they occupy with their actual volume. Okay. இதை தாண்டி there are few more which are important. நான் அதில் மேலே எழுதுறேன். No interaction, no interaction between molecules. There's no interaction between molecules. One. No interaction between molecules na ideal gas. Inert gases are very close to being ideal. Okay, gravity neglected. At absolute zero, motion stops. அதாவது when at absolute zero, what happens 3/2 kT will become 3/2 into k into 0. basically kinetic energy becomes 0. அப்போ என்ன, velocity becomes 0. so when velocity is 0, we can tell that motion stops at absolute zero. Absolute zero is 0 degree Kelvin. 0 Kelvin or minus 273.5 degree Celsius. Okay, are you clear with this? Okay. That's not necessary. Thank you so much, Mary Wells. Okay. Okay. All right. Thank you. MMC experience பத்தி சொல்லுங்க. This is for people who are in the end. Okay, NEET exam எழுத போறாங்க. So I can't waste their time by talking about my experience. Sorry. I'll definitely in one video, but not today. Okay, paka. So this is all my postulates of kinetic theory of gases. Now there is something called as RMS velocity. People they do not what they don't derive usually இதுக்கு. I will I'll show you why it's in such a way இந்த மாதிரி derive பண்றாங்கன்ட்டு. See, let's say I have a container. Okay, this concept and the other concepts which come after this are pretty important. Okay, all right. Okay, did I postulates of kinetic gas equation? Did I write the kinetic gas equation? No, I'll write it down on 1 minute. 1 minute. I'll finish RMS velocity. See, you have velocity in moon direction: Vx, Vy, and Vz. Okay. RMS is nothing but root mean square velocity. Okay, it's not average. It's root mean square. Okay, which is okay. Now let me find force exert. Okay, paka derivation in the basics and I'll go. You have a container with a length L, breadth L, and height L. Okay, a particle is moving with Vx velocity. Vx velocity. It's moving. Okay, it goes collides. Okay, collide against the wall. Collision are there. Elastic collision. And okay, the force exerted is nothing but momentum change. Okay, momentum is nothing but mass of the molecule into velocity of the molecule divided by the time taken. Okay, say it went from the one end to other end to collide. Okay, so the time taken will be L divided by time taken is equal to velocity. Okay, velocity L by velocity is equal to time taken. This everyone knows. So I am writing. So initially this is at this end point. In the end point இருந்து இது இங்க போகுது. இங்க போய் collide ஆகுது. From this point to this point. Okay, so this time t can be written as m into vx divided by what is it? L by t, L by vx. So m vx square divided by L will be my force applied on the wall. Okay, this is my momentum, this is my divided by time, this is my force applied by an individual molecule. Okay, all right. But force divided by area of this cross section எவ்வளோ? L and L அப்புறம் என்ன? L square. Force by area போடுறேன். area புதுசாக ஆட் பண்ணுறேன். by area L square. So ultimate equation will be let's take this m v x square by L cube. This will be my pressure. Okay, this is vx square in ஒரு direction. Okay, vx direction. Now taking average of of everything. Okay, if you I don't want to explain that inga, but if you take average for everything in all directions and write it in terms of RMS, your pressure will be equal to m 1 by 3 m v RMS square divided by volume. Okay, this will be my pressure. Paka, clear? Usually they don't derive it in for NEET level, but I still have to do it. Okay. Tarun Krishna, what is the weightage of thermal physics in NEET? Thermal physics ஓட weightage in NEET examination is கொஞ்சம் கம்மி தான். Okay, you'll have at most 2 questions or 3 questions coming from this entire thing. Thermodynamics, thermal properties, and KTG. In the unit length, you'll have 2 or 3 questions, 2, 3 or 4 questions max. Like அவ்வளோதான் கேட்க முடியும். Okay. You'll have 1 question in thermal properties, one question in thermodynamics. KTG வந்தா எப்பயாச்சும் வரும், இல்லைனா வராது. Alright, fine. This is my pressure ஓட equation. பக்கா clear? Okay. Alright, இப்போ வந்து there is we figured out there is volume இங்க. Okay, volume இருக்கு. PV is equal to 1 by 3 mv RMS square. PV is nothing but nRT, but in the case it's nKT, because for single molecular mass nKT is equal to 1 by 3 mv RMS square. Here now, yeah, I could write it in a video. And then, yeah, no reply. And then PV is equal to 2 by 2 multiply பண்ணா P half okay, 2 by 3 kinetic energy. Okay, this is all the possible derivations of this equation. This is until ultimately you want kinetic energy Ke is equal to 3 by 2 PV. Okay, sir, we saw this somewhere else, or Anna, we saw this somewhere else. Anything? Inga 3 by 2 nRT, 3 by 2 nRT is equal to Ke. nRT can be written as PV, so 3 by 2 PV is equal to Ke. Derivation done. Okay, paka. Yeah, so my kinetic energy is equal to 3 by 2 into PV. All right. Okay. Okay, when will chapters be mixed in? அது அப்படி கேட்குறாங்க. Like KTG plus thermodynamics. See, thermal properties, thermodynamics, KTG. You can mix anything you want. Okay, I don't know when they'll ask, but questions are there. It's possible for them to ask in the version. You just have to prepare accordingly. Okay, see, KTG la you have this one. Okay, இதை வச்சு kinetic energy of in system கண்டுபிடிக்கலாம், and then அதை வச்சு adding it to thermodynamics, yeah, internal energy change கேட்கலாம். அதை அப்படியே அந்த சேஞ்ச் சே இட்ஸ் given to an object, இவ்வளோ எனர்ஜி கொடுத்துருக்காங்கன்ட்டு. ஓகே, இந்த ப்ராசஸில் இவ்வளோ எனர்ஜி சேஞ்ச் இருக்குது, அந்த எனர்ஜி ரிலீஸ் இஸ் given to an object for thermal expansion. Okay, it can be mixed. Okay, they can ask சும்மா டைம் வேஸ்ட் பண்ணணும்னு எனக்கு ஆன்சர் எப்படி வேணால் கேட்கலாம் பேசிக்கலி. ஓகே, ஃபைன். All right. Okay, I hope it's clear. Okay. I'll tell you what RMS velocity is first. நான் இங்கே எழுதிட்டேன், but I'll tell you what it is proper. See, I have few molecules, few molecules with certain. Okay, thank you, Safura. Okay, see, I have few molecules with few velocities. Okay, paka. Say 2 meters per second one. Say 5 meters per second one. Say 10 meters per second one. Okay. Root mean square is nothing but root, okay, of the square of these. So it will be 2 square plus 5 square plus 10 square. Okay, this is my thing. இது வந்து divide the entire thing by 3 அப்புறம். This is basically what RMS velocity is all about. Okay, so when they give you values in the மாதிரி 2 3 4 5 6 அப்போனா take everything 2 square plus 3 square plus 4 square plus 5 square plus 6 square divided entirely by 1 2 3 4 5 6 divided by 5. Okay, okay, அவ்வளோதான். This is what my RMS velocity is. Root mean square. If you see here, we found out இங்க இருந்து 3/2 RT is equals to half m VRMS square. Okay, so 2 cancel. Then we can write 3 RT by molecular mass under root is equal to my VRMS. Paka? Done? Clear? Okay. Yeah. Now, this is the one, VRMS. Another, we have few more. That's your average, not mean free path. Wait. Not mean free path. We have average velocity, okay, இதெல்லாம் நம்மகிட்ட இருக்கு. We have other velocities as well which we use. Now before going into that, we know RT by M is equal to, பாருங்க, I derived it starting here density கண்டுபிடிக்கும் போது R RT by M equal to T by D. மாற்றி எழுதிக்கலாமா? So basically in the RMS velocity can be written as root 3P divided by D. Okay, period. Okay, Paka? Clear? Okay. I'll solve you one question. Say I have oxygen, okay? The velocity is v at a particular temperature. Okay. Temperature வந்து double பண்றான். Temperature is double. Okay. And then my molecule is disassociated. Fine. What will be the new velocity? See, oxygen இருக்கு இப்படி O2 O2 இருக்கு ஃபைன் பக்கா when you heat பண்றேன் ஓகே பக்கா ஹீட் பண்றேன் the temperature becomes 2T and then the molecule splits. Fine. So since I know it's root 3 r 3RT by m equals to my velocity v. Since if temperature is doubled, it will become root 2 into 3RT by m, and molecular mass is halved, so it will become divided by 1 by root 2. And in the inga by 2 varum, if I take it out, it will become 1 by root 2. So basically they'll get multiplied. So you'll have 2 into root 3 RT by m. So this is my VRMS. 2 into V. So the final velocity of each individual molecule of oxygen is 2V. Paka. நான் ஹாலிடே ரெயின்சிக்கில் தான் ஃபிசிக்ஸ் படிச்சுட்டு இருக்கேன். வீக் பாயிண்ட் நாட் டிப்ஸ் ப்ளீஸ். ரீனா நீங்கள் super, thank you Safura. See, the questions are super simple, everyone can, it's simple. Reena, are you going to write exam in the varsham or next year? Tell me, 2026 or 2027? Just tell me no, let me know, I'll solve a question adu varaikum. In 10 minutes we'll finish off the entire concept. Okay, one more question. Okay, they might ask in the mari where they would give you the pressure, they'll give you the temperature, okay, they'll give the velocity as well. Otherwise you find the molecular mass. This is given, this is given, this is given, this is not given. Otherwise you find the molecular mass. Okay, either temperature which we can find or molecular mass which we can find. I mean temperature which it's RT by m, obvious. இந்த மாதிரி கன்ஃபியூஸ் பண்ணுறதுக்கு டேர்ம் கொடுத்துருப்பாங்க. அண்ட் தென் இதை வச்சு we are supposed to find its RMS velocity at what different pressure and different volume. Okay, or a different condition of temperature as well, something. So the question goes like, an unknown gas. I'll come to you. ஒரே நிமிஷம் ரீனா, can you tell me what is Halliday? Is that the book? I've never seen. Resnick, Halliday, Resnick. Are they authors of some book? I don't know. Just tell me now. Okay. So molecules of a gas or a velocity is on the 200 meters per second. Okay, fine. And at 27 degrees Celsius, Okay, temperature is also given. Temperature is also given. Fine. Pressure is 5 Newton meter square. Fine. Idhila vande these are the conditions. Okay, now I have to find when the temperature is 127 degrees Celsius and when the pressure is 0.05 into 10 power 5 Newton per meter square, what will be the velocity? So inga vande you have initial pressure, you have velocity and temperature. Inga you have final temperature, final pressure, you have to find velocity. Okay, this is konjam complicated question, but still you could solve it though. NTA, I ask questions like this because when you have pressure, okay, when you have so many values, you will be like, say, kuduthirukanga, you have to use it to solve it. But when you see konja formula konja uttu pathina, you either have temperature or pressure. Okay, so you could use either of them. But you know, pressure marumbodhu density will change. So let's not take that. Let's take just temperature. So my RMS is proportional to root over temperature. So V by V dash is equal to root over T1 by T2. Initial temperature is 27 degrees Celsius apona 300. Final temperature is 127 degrees Celsius apona 400 under root is equal to my velocity, initial velocity, which is 200 meters per second divided by final velocity. V final velocity is equal to 200 into root 3, I mean 100 root 3. This is your previous year NEET question 2016. Okay, when you have so many values, just don't confuse yourself. Okay, now oh, undergraduate level books. Okay, are you preparing for NEET or JEE? I don't know. If owning a UG level textbooks solve பண்றதுக்கு, if where are you at physics இப்போ correct? If you are able to solve நல்லாவா இல்ல கொஞ்சம் improvement இல்ல அதனால you're worrying, that's what you're worrying about, or you're not able to solve anything? Just let me know. I'll finish this off. Okay, it's a book. Okay, fine. Now we have a few more velocities. I'll come back to Reena in a bit. Okay, we have most probable velocity, which is root 2 RT by M, or root 2 P by D. Okay, this is most probable. And then you have average, which is root 8 RT by pi M, or root 8 by pi P D. This is your average velocity. Okay, when you plot a graph between, then see, this is my graph. This is my velocity This is my number of particles in that velocity. Number of particles or number of atoms or molecules with that velocity. Okay, so when you see velocity, it will increase in the mari. Some molecules are stationary, some molecules are super fast, but meena வந்து they'll be in the range. In the range, if you see, most of the molecules are here. Okay, most of the molecules are velocity. Average velocity is here. Most probable velocity, average velocity, this will be my RMS velocity. Most probable velocity வந்து velocity with the highest mean velocity possessed by the largest number of molecules, and then this is my average velocity. Average, this will be my RMS velocity. If you see the formula, okay, mostly வந்து it's root 2. Average வந்து it's 8 by 3, yeah, root over 8 by 3, 3.14159. So it will be around 2.6 ல இருக்கும். So it's 2.6 in root 2.6 into RT. This will be root 2 into RT. That is RMS is root 3 into RT. So other which you can find which is greater. Your most probable is the least. Next you have average, then you have RMS. Okay, paka. Fine. This is Maxwell's distribution curve. Just have a look into that. Okay, and then we have mean free path. HC Verma, I preferred HC Verma, I used it. Okay, in the version you are going to write. Okay, okay, mean free path lende, see, basically when you have molecules, in the postulate we saw interaction between molecules are just collisions. Skip பண்ணிட்டேன். Collisions are present between molecules. Okay, mean free path is the average distance between two successive collisions. Okay, it is represented by lambda m. Okay, and the formula derivation is not there. Okay, just remember the formula. It's derivation இருக்கு, it's not necessary இப்போ. இது அதிகம் மாதிரி 1 by root over 2 into n pi d square. Okay, this is your root mean. This is your mean free path. Okay, I'll explain all the individual terms in this first. Okay, this is my mean free path. Distance between two successive collisions. Okay, this is between two successive collisions is your mean free path. So when you have this, your d is the diameter of the molecule. Okay, n is the number of molecules per unit volume. Okay, so this is your mean free path. Let's see, you will find how much distance is there between two successive collisions. So we will have ratios. கரெக்டாக ரேஷியோஸ் இருக்குமா? சே அ மாலிக்யூல் அட் ஒன் டெம்பரேச்சரில் சேம் மாலிக்யூல் ஓகே கொஞ்சம் கொஞ்சம் குட்டியாக இருக்குது. நம்பர் ஆஃப் மாலிக்யூல்ஸ் per volume. Okay, fine. Okay, paka done. All right, we'll solve few equations. Okay, first before that, atomicity, molar mass and average velocity. Can you why do you have atomicity here, Ria? Okay, all right. Okay, now now there is one thing I have to tell you. Okay, or graph, we know PV equals nRT. Yeah, अपना PV by nRT is equals to 1. Okay, it will be a constant number. இது எல்லாரும் sure? Okay, so when I plot, so for PV by nRT to say pressure only. Okay, ideal gas oda line வந்து இப்படி இருக்கும். Ideal gas, it will be a straight line, constant. Okay, அதே வந்து if you take a real gas, இப்படி இருக்கும். These are இதெல்லாம் வந்து ரியல் கேஸோட curves. Okay, now you have to you're supposed to find which one is at higher temperature. This is ideal gas, this is your real gas 1, real gas 2. So real gas 1 ku real gas 2 ku என்ன relation, relation இல்ல, we're supposed to find which is at higher temperature. Okay, this curve வந்து இப்படி மேலே போகாது, it will go like something வந்து it will go like this and go இப்படி. Okay, எனக்கு இதில் வரைய வரல, so it auto corrected into in that way. But yeah, basically I told you that at higher temperatures and lower pressure, okay, gases tend to be more ideal. Fine, this is at a same pressure la, say R1 is more closer to being ideal than R2. அப்போனா என்னது, my R1 is more ideal, அப்போனா R1 has higher temperature. So R1 or the temperature of T1, R1 or temperature T1 is greater than temperature of T2. Okay, paka. These are the utmost maximum questions they can ask in this chapter. இவ்வளோ கஷ்டமாக கேட்குறது. Okay, they won't ask much questions from this. I think I've covered almost everything. Just why do you want atomicity? அது மட்டும் just let me know, and then அதுக்கப்புறம் we'll end this. Okay, okay, I'll give you one or it's in a tricky question. These are like இது வந்து கொஞ்சம் கன்ஃபியூஸ் பண்ணுற மேக்ஸ். ஓகே, எவ்ரிதிங் இஸ் டன். I'll give you one question. Say oxygen at a temperature T has a kinetic energy of 1 molecule of oxygen, or 1 mole of oxygen. 1 mole of oxygen has a kinetic energy of 0.33 electron volts. Okay, how much will be the kinetic energy of nitrogen in the same temperature? 1 mole of nitrogen. Same temperature is what matters. So when the temperature is same, kinetic energy is the same. So since their temperatures are same, they'll have the same kinetic energy. Okay. Okay. Now say I have a gas molecule of RMS velocity 300 meters per second. When the temperature, what will be the RMS velocity of a gas whose temperature is twice, and whose temperature is half of it, and molecular weight is 3 times of it? What will it be? Basically, this is my RMS velocity, root 3 RT by M is equal to 300. இப்போ வந்து 3 times of its molecular massனா 3 இங்கே வரும், and half of its temperature na by 2 இங்கே வரும். So it will be 300 divided by root 6. Yeah, it will be, if you solve it, root 6 into 50 divided by root 6, 50 root 6. This will be the answer. Okay, 3 times the molecular weight, half of the temperature, 50 root 6 will be the answer. These are at most the questions they ask NEET level. So yeah, idoda I think we'll finish the chapter. We finished kinetic theory of gases pakkava. I didn't miss anything, Nike. Every concept is covered. Yeah. So yeah guys, Reena, keep practicing questions, don't give up. The one thing that helped me to overcome chemistry was thinking that it was an easy subject. When you see stuff, okay, see 11th and 12th என்ன கெப்பாசிட்டி ஸ்டூடெண்ட்ஸ்க்கு இருக்கோ அந்த கெப்பாசிட்டிக்கு தான் வந்து syllabus are also made. Okay, you will be able to understand it somehow. Yeah, because everyone has the capacity. When you think it's a weak, is your weakest subject now, you'll be weak in that forever. Okay, I was weak in chemistry. I thought I was weak in chemistry, but I did end up scoring good poga because I had my teacher who told that you're not even trying because you are scared of the subject. Okay, let's not create that sort of mindset while approaching physics, because physics is actually simple. When you imagine stuff, when you just understand how things work, it's simple. Okay, so don't worry. Yeah, time. All right, I think yeah, hostel pono guys, time much. So yeah, I'll end the stream now. If you have any doubts, ask me in the comments. Thank you so much for watching the live. Thank you. Thank you so much, guys.